Okay, hello. I'd like you to indulge me for just a second, and I'd like you to cast your minds back and think about the first time that you enjoyed programming. So I'll just give everyone a second and see lots of cogs whirring. If you're anything like me, it was probably like a moment where, you know, you'd been typing this code in that you didn't have a clue what it was doing, and like you're just like, yeah, this is going to be great. And then all of a sudden you hit run, and it worked. And it's like, yes. Or in my case, probably like running around the room with my hands like above my head going, oh my God, I can't believe it worked. Joking aside, that's an important feeling. And it's one that everyone will have had at some point in their kind of coding careers. And it's a very important source of motivation if on the path to becoming a programmer. And so the question I have is, how can we make sure that the maximum number of people have that experience at least once, and therefore have the choice to go on and say, you know what, I do enjoy this, I'm going to go on and become a programmer. And what I'm going to speak about today is an attempt to answer that question. It's called Sonic Pi. For those of you who haven't heard of it, it's a program that combines Ruby with synthesis to allow you to make music with code. So just a little signposting of what we're going to go through today. I'll take you through the bare bones of Sonic Pi's API. It's a very small API. It's not Rails. Don't worry, I can get through it in 10 minutes. Then we'll go through some examples of the kinds of things people have been doing with it, and I'll show you some of my mad experiments. And then we'll talk about how it relates to education. So just to start, really, it's a free open source project. You download it as an application. It's cross-platform. So it works on Windows, OS X, Linux, and it's pre-installed on every Raspberry Pi. And so the reason for the name is the fact that the Raspberry Pi Foundation have sponsored the development for this as a project to allow kids to, you know, they've bought their Raspberry Pi for 25 quid, taken it home, and like, what can I do with it? And this is part of the package that they get. And I think they've just recently announced they've sold 8 million Raspberry Pis, so that's a lot of Sonic Pi out there in the world. And it's hopefully going to be a lot of people's positive first introduction to making music. So, without further ado, let's have a look. This is the API in kind of in 4 parts. We've got synths, samples. I was trying to get 4 S's, so there was a bit of a mnemonic. Effects and sequencing. So we'll just crack on. So, Year 5 at school, new computer science class. Teacher's very nervous because they don't know what they're talking about. We have our first program. I'll just get this down on the screen for you. Can everyone read that? Yeah? Okay. So, we have our first program. Play, 60. So this is all Ruby. So if I do puts, if I can type, which is not a guarantee on a day like this, you can see puts Ruby version. We've got a little console over on the right, and we've got a nice beep. So first thing the kids do. Oh, what happens if I do this? Oh, okay, it gets higher, and then yeah, and then of course if it's a year 5, they're like, oh well, yeah, obviously I want to type in like. Yeah, I couldn't hear that. Oh right, okay, I'm going to play 1. No, okay, that's oh yeah, there we go. Okay, so immediately you've got like kids are experimenting, and you've like straight away in this very, very simple program. There's no require statements. There's no like, oh, you just have to type in all this stuff to get up, or you just have to download Emacs. You know, there's no like the getting started is very quick, and the feedback loop is very small, and this is really essential. So like Sam Aaron, the creator of this, was kind of using Logo as his inspiration for this, which is like a really, really simple kind of paradigm. And our rule with the Sonic Pi API is if a 10-year-old can't use it and understand it, then it's not going in the API. So it's a nice gold standard, and it would be nice if someone made a web framework that followed the same rules, maybe. But so anyway, we've got play. You can also, yeah, it doesn't sound too good, but yeah, you can use floating point numbers, and if for the musically inclined, you can say C, D, so on and so forth. So cool. We've got a play command. Let's do our first tune. So Frère Jacques, everyone knows Frère Jacques. It's all right. We've worked out what the notes are. We'll type them all out. Oh. Okay. So I'll just debug that. Yeah, they all kind of happened at the same time. So unfortunately, the screen resolution isn't great, so I'm missing a little bit off the end of the log. But what you'll see is that they all happened at time 0. So they all happened at exactly the same time, despite the fact that they are one after the other. This is intentional. It's not. It's a feature, not a bug. So there we go. That's your 2 commands. Play and sleep. Very simple to grasp, get a hang of. What's interesting about those is that because we have a flexible pitch system, floating point numbers and all the rest of it, and a flexible timing system where you can sleep for any amount of time, you can represent most of Western music with 2 commands. It would look crazy, but you can represent most of Western music. So it's actually a very powerful, I mean, this kind of seems obvious, but it turns out there's a very powerful level of abstraction. So we're going to move on. So that was, no, we're not going to move on. I haven't explained all the synths yet. So at the moment, it's just beeps, which, you know, sound okay. So we'll just play 60 with, this might be a bit loud. So there's a number of synthesizers built in. You don't have to just stick to beeps. This is a classic TB303 synth. There's a documentary about it on YouTube. Thrilling. Okay. And one more thing. The rest, the API mostly takes this kind of format, which is where you can have parameters after it. So with a release of 2, you can look this up in the docs, which are built in. A release of 2 means it lasts for 2 seconds. So that's all we need to know about synths. Let's move on to samples. Okay, sample. Let's pick the first one. It's good. Okay, so we've got our synthesis. This is WAV files. This is just a WAV file that exists on the system. It's built in. That's cool. I can use parameters. I can play it twice as fast. Or I can play it half as fast. Or a quarter. The nice thing about samples is they're extremely flexible in musical situations, and you can get so much mileage out of just like a tiny bit of code. So if you're actually going to use this in anger, this nice. This is the RMM break. It's famous in its time. So it's a loop. So we're going to want to loop that, really, aren't we? Have to sleep. So what we can do is we can say sleep for the sample duration of loop RMM. That should do it, I think. And, you know, year 5s, they understand this. They have the urge to rave, and, you know, they can, you know, they're like GABA or whatever. Let's do a bit of that. Maybe a Bristol year 5. Okay. However, this sample duration thing is a little bit goofy, if I'm honest. So we like to instead use sample BPM. So this scales like the current tempo to whatever sample you give it. And so now, if I say that, I can say sleep for 1. I'll bring the rate back down. A musically astute of you will realize that there's not 1 beat in that bar, there's 4. So I'll just do that. Okay, and you can see that's one sample, but it's being looped around again and again. Okay, so that's samples. They're extremely fun, and we'll get onto some examples of those later. Another thing you can do with samples is you can specify a start and end time. So the start and finish are scaled between 0 and 1. So I can play, say, the first half of that. Oh, sorry. I can play first quarter. Yep, that works. First eighth. Yeah. Okay, and that was the kind of sound I wanted, actually, because the next thing I'm going to demonstrate is the effects. So in music, we need loads of effects. Need to buy loads of expensive units that you put in a rack mount. It looks really cool because there's all the lights and everything else. So Sonic Pi comes in with some built-in effects. So this is the reverb. Let's make that a bit more obvious. The funny thing is that because of this room, there's a natural reverb anyway, so we're going to have to kind of... hey, there we go, yeah. So that sound is not coming from the room, that's the reverb effect being applied to the first eighth of that sample. And there's a ton of effects, which I'll show you how to get to in a second. Just the last thing, sequencing. So how are we doing? Yeah. I can tell what you're all thinking at the moment. You're thinking, yeah, okay, so you can make some beeps and you can play some samples, and that's fine, but you wouldn't actually be able to do anything with it because you'd be worrying about all your code all the time. So we kind of thought about that, and it's true that it would be difficult to make anything musical if you had to worry about not running the same loop twice or whatever. So there's this construct called a live loop, which again, year 5s in schools are using with success. So I'll just talk over, so I'll make this a little bit quieter. So a live loop, the implementation is pretty cool. This is actually a function and a thread, so I can redefine it and it will stay in time. Or I can change this here. Let's make it a short release. Yeah, and so I can start to play around with this in real time. I'm going to skip ahead. And hopefully you can kind of start to see how this sort of starts fitting together. So this live loop thing is extremely useful, and it's actually quite a practical way of making music. I'm finding I've not run out of mileage with it yet. The really nice thing is, though, that because of the timing system in Sonic Pi and the threading system in Sonic Pi, we can do things like this, where I say, I'll sync this up to demo. I don't, oh, yeah, okay, I will. Let's have 4 to the floor. Sample BD tech, sleep 0.5. Is that going to work? Let's try it. Okay. So what's good about this? We have 2 threads running. They're in time with each other. This is amazing. So from a programming music perspective, not only is this multi-threaded, but it's multi-threaded and it actually works, which is a rare, rare experience. I can actually start to get my teeth into this. So when I started with Sonic Pi, probably about a year and a half ago now, I could already program Ruby, and I'd done a music degree. And as part of my music degree, that was kind of my introduction to programming. I used these really weird, esoteric music programming languages. And I'm not going to make myself any friends here by saying they were universally dreadful. Like, they were so bad. I can't describe to you how painful some of these things are to use. And then it came to this, and I got to use Ruby to make music, and it was in a kind of some sense of it being actually intuitive and working. So I was thrilled at this point. So I went off the deep end and started coming up with loads of examples. So that's Sonic Pi's API, pretty much. I'm hiding a couple of bits from you just for housekeeping purposes. There's a help section up at the top, and the resolution of the display is conspiring against me at the moment. But there's this whole thing here. We have the experience is really important. So we built in documentation. There's 3,000 words of tutorial that take you right through every possible step. So if you're going to go home and try this out yourself or with your kids or whatever, there's stuff to help you all the way. Let's take an example from here. Let's kick off with that. This might be a bit loud, in a good way. Okay, so this is an example from the examples bit that's in the help directory. That's the whole thing. That's only using the commands that I've just shown you in 10 minutes. So, and we've definitely had kids in classrooms doing similar kind of work themselves, and they're really enjoying it. And hopefully, if you're kind of fancy having a go, you could get on this too. So, where does Ruby come into this? This is just Ruby, so there's you've got all the power of Ruby at your disposal. And so one of the first kind of things I tried was I wanted to make a sampler. So I had our loop arm sample from before. So when I was doing my final year project at university in music, I was using this thing called Max MSP, which is like this graphical patching language. Not the worst, but still pretty bad. And I wanted to make something that could slice samples up. And it took me maybe 3 months, partly because I had no idea what I was doing, but also because graphical programming environments are tough. So let's do the same thing in Ruby. We'll build it up little bit by bit. Okay. Puts, we've got a range, Ruby's range. It has a method called step. So let's step over the range 0 to 1 in 16ths. We get an enumerator. Let's stick 2A on that. So you can see up here, this is, you can see the first 4 in the sequence anyway, that we've divided the range of 0 to 1 into 16 slices. And then this is part of the fun, was just delving into bits of Ruby's like enumerator class and stuff like that. That solving musical challenges with Ruby actually turned out to be a nice way to sharpen skills that you wouldn't necessarily be using at work. So each const takes each consecutive thing in the sequence. So it takes the first and the second item, and then the second and the third item, third and the fourth item. We can see that up in there. And we're nearly there, so we just need to collect those into start and finish. Start S, finish F. Let's put 2A on the end of it. Okay, so we can start to get our slice parameters set up for our sampler. I'm going to cut to the chase here and say here's one I made earlier, because right. So I'll just I'll get rid of this so you can hear the sample by itself. So Another example of the sample thing is that you can use any sound that's on your file system. So I've just got a path to a file that's on my system. It's of Bobby McFerrin. Just take this off the radio. And that's, that's the same. I can make Bobby twice as fast. Yeah. OK. So using this example again, going back to this one. We've got the slice points thing. We're stepping through it in 16ths. We'll take each consecutive one, collect them up. And then here's the important bit. We're going to shuffle them. And I forgot to explain what a ring was in my API thing. But basically, it's an array where if you go off the end of the indexing, it'll loop back around to the start. So if you try and access the fourth element in a 3-element array, it will just give you the first, and so on, if that makes sense. Hope so. And we're going to go around and around, and we've got our sample of Bobby.
It's 10 o'clock.
Thanks, Mac. Thank you for that timely reminder. Good way of doing Pomodoro. That's a built-in feature of OS X, by the way, but not what I wanted to talk about today. So we've got our sample of Bobby. We take a random start and finish time, a slice, and we play it back with a bunch of stuff. So it sounds like this. And hopefully, if I've explained it well enough, you can start to see how Ruby comes to your aid when you're trying to build these musical constructs. Now, this isn't a dedicated bit of hardware that you have to keep around or spend loads of money on. You can use it with any WAV file that's on your system. And it's, it took me a long time to do this in MaxMSP. With Sonic Pi, I could do it fairly quickly, and I could fit it in a tweet, which was pretty good. So we can change. So we've got some examples there of using samples. I'll just give you. There's one I wanted to share here. So I haven't really talked about the synthesis side of things very much. When I said the whole of Western music, it's possible. One of the things I did in the run-up to BathRuby was to get authentic-sounding NES synths on there. So I wanted to kind of bring retro gaming sounds to Sonic Pi. Play pattern timed. The nils are just a rest, and we've got musical symbols, but that's basically it. And so I'm using different synths. I've got chip bass, which is the bass channel, triangle wave, chip lead, which is a pulse, and then chip noise, which is my personal favorite. So yeah, that was a little bit of original research for you at BathRuby here. What's fun? I love chip noise. It's so good. The thing on the NES, it had these things where it had a channel. So when your spaceship crashed into something else, that was the noise you'd get. And I was like, okay, how do I replicate this? And this is one of those instances where music can be a fascinating problem domain. So I started looking into, right, how am I going to make this noise thing in the back end of Sonic Pi? Turns out the answer is linear feedback shift registers, which are the basis for things like radar and cryptography. But they had a 4-bit number to work with. How can we make it sound as noisy and awful as possible? And the clever people at whichever chip company came up with that, probably Texas Instruments, were like, yeah, let's do this. And so what I do find again and again is, as I'm researching musical things, we go off the deep end and ends up finding some nice new programming thing. This is just come in on a GitHub issue. Someone was like, can we add Markov chains to Sonic Pi? And we were like, yeah, go for it. Tell us what you want. And this was the first bit of Ruby he'd ever written. It looks a lot better than the first bit of Ruby I ever wrote. And he did a Markov chain for London Bridge. So he's trained it on London Bridge, but we now have a Markov chain which is kind of like London Bridge, uses the same intervals, but you can hear it's not. It's a new musical expression. I think that's a really cool example. the implementation is like 60 lines, and it's all within Sonic Pi, it's all Ruby. So you can go as crazy as you want with this, really. So hopefully I've given you some examples of kind of what it can do. The enjoyable bit for me, though, is live coding. It's a different challenge to the kind of programming you're normally used to. So if you program for web servers or what have you, there's no concept of time in web servers. The only time that matters is as fast as possible. Like you won't get on Hacker News saying, I've got a web server that serves requests in rhythm. Like that will never happen, although someone will prove me wrong. Music is a completely kind of different challenge to that, and you want to make sure everything happens in time. And because it's time-based, you can actually experience that passing of time as you're programming, which is a different interaction with the code than you might be used to. It's not sort of compile and run, or I'm just going to write this, test it, refresh the browser, see if it works. It's like you can actually edit the code in response to your moods and feelings and thoughts and dreams and ambitions in a way that, the effect is cyclical, and it's a lot like playing a musical instrument, and it's a lot of fun. I think that's a lot of fun. I hope that some of you guys are going to go home and try it out with your kids, try it out with your parents, grandparents. How awesome would it be if you could talk to your parents and they actually understood what you did for a living? It might just be me, but it's, I've been playing with this for quite a while now and not bored of it yet. So I'm going to finish up now with a little thing. I just want to say thanks to the BathRuby for having me. Thanks to all of you guys for listening and being a good audience. Sponsors have been great. If you want to come speak to me about this or Heroku or anything else afterwards, just come and shout me, say hi. And I'd really like to speak to you all. If you found that you didn't learn anything about music or Ruby during this talk, definitely want to speak to you, because then you could contribute to Sonic Pi, and that'd be fun. And yeah, I'm going to get to the rocking out portion of the evening, the morning. So, without further ado, this is going to be me. Thanks very much.
Hi, everybody. We live in a time of extraordinary change. Change that's affecting the way we live and the way we work. New technology replaces any job where work can be automated. Workers need more skills to get ahead. The question we have to ask ourselves is, how can we make sure everyone has a fair shot at success in this new economy? The answer to that question starts with education. Now we have to make sure all our kids are equipped for the jobs of the future. Developing the analytical and coding skills to power our innovation economy. Today's auto mechanics aren't just sliding under cars to change the oil. They're working on machines that run on as many as 100 million lines of code. Workers of all kinds need to be able to figure out how to break a big problem into smaller pieces and identify the right steps to solve it. Computer science isn't an optional skill. So, I've got a plan to help make sure all our kids get an opportunity to learn computer science, especially girls and minorities. From students teaching each other to code, to teachers adding programming to their classes. That's what this is all about. Each of us doing our part. That's what this is all about. Each of us doing our part. That's what this is all about. Each of us doing our part. That's what this is all about. Each of us doing our part. Thanks, everybody, and have a great weekend. Thanks, everybody, and have a great weekend. Thanks, everybody, and have a great weekend.
Thanks very much.